economists use graphs to represent a lot of their analysis. So we'll take a while here to review how graphs work and see how we'll be applying them throughout the lessons. You're familiar with graphs like pie charts, which show you how one sum can be divided up into its parts. You're also familiar with bar charts that show you how a sum changes over time or can be divided up also into its parts. In economics, we're going to use graphs in two-dimensional space, and these graphs usually represent relationships between two variables, or in some cases, relationships among three variables. What we'll do in this lesson is show you how those graphs work and prepare you for tools that we'll be using in other lessons. Let's start by having a look at the two-dimensional graph space. We have a vertical axis along which we measure the quantity of one variable, and a horizontal axis along which we measure the quantity of another variable. And usually these two variables are related in some way that the economist finds interesting. Let's look at an example of information that we represent in this two-dimensional space. Suppose we want to graph the relationship between two variables, consumption and household income. Consumption is the amount of money that a household spends on goods and services, and income is their income, the money that they take in from work and other sources. Now, how are we going to represent the relationship between consumption and income? Let's start by graphing income on the horizontal axis, and I will use this abbreviation INC to stand for the household's income. And we'll measure this income in dollars. So I'll put a dollar sign here to remind me that everything that's measured on this axis is measured in dollars. Now I can calibrate the axis by marking off these tick marks and putting numbers along them so that I have a scale along which to represent my information. Let me let each of these tick marks represent $10,000 worth of annual income. So the first tick mark here I could label 10 for $10,000. The second tick mark I could label 20. The third I could label 30. And I might want to be careful here not to put too many numbers close together or the graph could start to get crowded and unwieldy. So what I'll do is I'll skip every other 10,000 and represent 10, 30, 50, 70,000. Here's 80. I'll skip it. 90, 100,000, 110, and 130. And the numbers, of course, continue as you go out. The numbers increase, representing larger annual incomes as you move to the right. On the vertical axis now, I'll represent the other variable, and this is going to be consumption spending, which I'll represent with the letter C. So as I increase my vertical altitude here, I'm increasing the consumption spending of this household. I'll put a dollar sign here to remind me that consumption is measured in dollars. And I'll do the same thing that I did on the horizontal axis. I'll calibrate using tens, and I'll skip every other one so that I don't get too crowded. Here's $50,000 in annual consumption spending. Here's 70. Here's 90. Here's 110. And just let the numbers go on up. Now, what I do in this space, now that I've created it, is I can represent information about consumption spending. Suppose I have a table of numbers, and one of the numbers that I have, suppose I have a table of numbers, and each one of these numbers represents the income spending information for a particular household. Each household, each data point that I have represents the behavior of a household. So I'm going to put data points in this graph, and each point will represent the behavior of one particular household. So suppose I have a household, and I know that their annual income is $30,000, and their annual consumer spending is $40,000. Now you might ask, how can that happen? If their income is only $30,000, how could they spend $40,000? Well, perhaps they have other sources from which to get money. Perhaps they have savings that they can draw on, or perhaps they receive payments from the government or other sources of income. So if I know that a household that has a $30,000 annual income is spending $40,000 a year on consumption spending, I will go up to this point and put a dot where those two numbers come together. Now notice, the horizontal coordinates of this point represent the income of the household, that is $30,000. The vertical coordinates represent the consumption spending. So see, each point in this space represents a combination of two pieces of information about a single household, their annual income and their consumption spending for that year. I can label this point with a pair of numbers that represent its coordinates. I'll write first the horizontal coordinates, that is 30, to represent their income, or 30,000. And second, I'll write the vertical coordinates of 40 to represent the spending data. Now, sometimes you'll hear the information represented here called the x variable, or this number called the x-axis. The horizontal axis is sometimes referred to as x, and the first number here represents the x-coordinate. Sometimes this axis is called the y-axis, and the number that's represented here is the y-coordinate. So the numbers in parentheses are the x and the y, the horizontal and the vertical numbers here, written side by side. And each point in this space will have two numbers, two coordinates associated with it. Now let's suppose that I have data on a lot of households, and I know the income and the spending for several households. I can represent the points in this space and form what we call a scatter diagram. The scatter diagram just tosses the points out in this space and looks at them. So why don't we do that? If I have information, say that a house that has an income of $10,000 was spending $30,000 that year, I can put a point here with a horizontal coordinate of 10 and a vertical coordinate of 30. Suppose I know that a household that had $90,000 annual income was spending 70. So let's put a point up here with a horizontal coordinate of 90 and a vertical coordinate of 70. By the way, what was that household doing? If they were spending less than their income, then they were saving the difference. And then, suppose I have a lot of other points. I'll just graph some samples here. Suppose I had a point like this one, and 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 so forth. Each point represents a combination of income and spending for one particular household. And as I fill in the information that I have, in each case I'm representing the household's income by the horizontal and the household's consumption by the vertical. This is a scatter plot. It's information arrayed in a two-dimensional space to represent two variables for each data point. That is, the income and the associated consumption spending for one particular household. Now, once you've got a scatter plot like this, the next thing that you're tempted to do is to fit a line to that information to notice the general relationship between the two variables. Notice, as we look at this information, in general, as income increases, consumption spending increases for these data points. We say that there is a direct relationship between income and consumption, a direct relationship or a positive relationship between these points. If I wanted to notice the general relationship, I could fit a line to these points that would look something like this. And this line represents the general relationship between consumption and income. That is, in general, for the points in this data set, as income increases, consumption spending increases. The thing that's important to notice here is because of the direct relationship, the line that passes through these points has a positive slope. Now, what does that mean, a positive slope? I'll get to that in just a moment. But I want to stop here and make the point that in economics, one of the first things that we do is we notice general relationships between data points. We notice, for example, that when income increases, consumption increases, we observe a positive or a direct relationship among the points.